Hello everyone, how are you? Welcome to Figyan, which is Physics Gyan. Now, if you want to watch this video in Hindi, just click on this link given above, right? Okay, so I hope you're all at home. Just stay indoors, stay safe. It is very dangerous outside. Now, I thought that now that we are all at home and you can't go outside, you can't go outside and play. So, let us take this time and try to learn something new, shall we? Okay. So before I was going to start this video, I remembered that many of my students come to me and they say that physics is beautiful. Like they really love the concepts and how to deal with science, which is everywhere around you. But somehow they start to lose interest in the subject. And you know what the reason is? Calculus. Yes. And I don't know, many of you might also have this general notion in you that calculus is difficult. Whenever these symbols of integration or differentiation come to you, you seem that, or I mean, physics start to look difficult, right? And we think that probably this is not for us. This is not subject I like. Let us go to biology or chemistry. But what if I told you that calculus is not difficult? It is very, very easy and it actually gives you a better understanding of the subject. So today I'll try to take this fear out of you of calculus, and for that we'll begin with differentiation. Now you all know that differentiation something looks like this: dx upon dt or dy upon dx. What is this and what does this mean? Let us try to understand this. So for example, let's say you had a function of y equals to fx. What does this mean? It means fx here is a polynomial in x. It could be a binomial, it could be a monomial also. So for example, it was, let's say, x squared plus 3x plus 2. This is one of a polynomial. Or it was x plus 3, or let's say it was just 2. It could be anything. But so this is like a constant, right? I want you to focus on these two. If I give different values of x, I'll keep getting different values of y. If I put x1, you'll be getting y1. If I put, let's say, x2, and you'll get y2. So for different values of x, you keep getting different values of y. And if we were to plot a graph using these values, right? So for different values of x, you get different values of y. So what you'll be getting is you'll be getting different points over here, and if you join all of them, what you get is a graph. So for example, let's say I just draw this rough graph. Now this is not a graph you are familiar with. I'm just drawing a rough graph just for the sake of reference. Okay. All right. Now what differentiation does is differentiation tries to tell you the slope of this graph at any point. Okay, what does this mean? It means if, let's say, you had a graph like this and someone asked you what is the slope, I know what you'll do. You'll take any 2 points. Let's say one point was this and one point was this. You'll say this is my change in y. What is this? This is delta y. You'll say this is my change in x, and the slope would become delta y upon delta x, right? Okay, but is this case same over here? See, this was a straight line, but this here is not a straight line. So if you try to find a slope on this point or on this point, or let's say on this point, it will be different for all of these because this graph is a curve, right? Okay, what differentiation does is it tries to give you the rate of change of y with respect to x. Okay, which is more or less, which is like a slope only. Okay, so let's say I took 2 points. One point is, let's say, x. For this I get a corresponding value of fx. Let's say I have x plus h. For this I get a corresponding value of f of x plus h, right? Okay, now what would be the slope with these 2 points? Now you know that whenever you want to find slope of a line between 2 points, what you do is you try to find delta y and you'll try to find delta x. Delta y would be f of x plus h minus of f of x upon delta x. Delta x would be h. Okay, so this is the slope. But if someone asked you, tell me the slope at this point, what would you do? Right now these are two discrete points, but to reach, or to tell the slope at this one single point, you need to draw a tangent at this point. Just forgive me because this is not a proper tangent. Yeah, this is better. The tangent at this point, and how to make these 2 points come down to one point. So right now the gap between these 2 points is h. If I try to reduce this gap to almost zero, if I keep reducing h and make it near to zero, right, which means very very small, this point will come like this and it will reach a place which is very near to this point. And when these 2 points are so close that it appears to us that they are just one single point, and if you draw a line, joining those 2 points, that would look like a tangent. And that is the instantaneous differentiation or a slope at this point. So what we are actually doing is we are putting limit h tends to 0. Yes, this is my derivative of y. This much. This is what differentiation does. But now you might say that this is not, I know differentiation. I know differentiation like these formulas. So are these the same? Yes. Remember how I told you that y is a polynomial in x? So let us take this over here. The polynomial is x to the power of n. dy by dx is given as n x to the power of n minus 1. So can we find this? Like, can we go from here to here using the concept that we just learned? Let us try it. So for simplicity, I'll just take x to the power of 6. Let's say y is x to the power of 6. Okay, this is my f of x. Now I want to find the differentiation. I would write that dy by dx equals to x plus h to the power of 6 minus of x to the power of 6 upon h. Okay, all right. And during all this, limit is h tending to 0. Fine. Now there is a small problem over here. How to find expansion of this? See, x plus h to the power of 6. It is, I mean, if it was x plus h to the power of 2, or you say x plus h square, I would have done it. If it was x plus h cube, you would have also done it. But x plus h to the power of 6. So somehow we have to use binomial theorem. And if you remember, in the previous video, we had learned a simpler way of solving binomial expansion. That was Pascal's triangle. So for example, you are to find x plus h to the power of 6, then you look at sixth row. So okay, let us try to expand this. X plus h to the power of 6. First term would be 1, which is this one. 1 into x to the power of 0, h to the power of 6, plus second term would be 6. 6 into x to the power of 1 into h to the power of 5, plus third term is 15. 15 into x to the power of 2, h to the power of 4. So this will keep going. Let us jump to the second last term. 6 into x to the power of 5 into h to the power of 1 plus 1 into x to the power of 6 into h to the power 0. Now, if you remember, I have to subtract x to the power of 6 from here. So, okay, if I subtract x to the power of 6 from this and this will cancel out. Only these terms would remain. Okay, but h is actually tending to 0, right? So whenever something is very less and you try to square it or cube it, it becomes even more less, right? For example, h was 0.01, and if you make a square of it, it becomes 0.0001. If it is 10 to the power of minus 5 and you make a cube of it, it becomes 10 to the power of minus 15. So that is why all these terms where we have h to the power of 6 or h to the power of 5 or even 4, we can neglect them because h is very less, and if we make it to a power of 6, it will be almost 0. So that is why we can neglect these terms. And only this term will remain because here h has a power of only 1. So it will be 6 x to the power of 5 into h upon h. It becomes 6 x to the power of 5. So remember, so d by dx of x to the power of 6 becomes 6 x to the power of 5. Simple. And this is how you can do for any expression, like for trigonometric also. For example, let us take sine x. Now I'll do it a little quickly. Limit h tending to 0, sine of x plus h minus of sine x upon h, right? This is the expression of dy by dx, or d of sine x upon dx. So this will come out to be, I'll expand it with sine a plus b. It will become sine x cos h plus cos x sine h minus of sine x upon h, right? Now, there's one thing you need to understand over here. If h is very less, that is, it is tending to 0, then sine of h will become almost equal to h, and cos of h will become almost equal to 1. So imagine this, it is very less. So let us say for a moment it is 0. Sine of 0 becomes 0. Cos of 0 becomes 1. So this is an approximation I'm doing over here, right? So this is sine x, right? Sine x cos h is 1 plus cos x sine h is h minus of sine x upon h. So this sin x and this sin x cancels out, this h and this h cancels out, so it becomes cos x. So what does this tell me? That derivative of sin x is cos x. That is, if you take a tangent at any point on the graph of sin x, it will come out to be cos of x, right? And differentiation is actually very important in physics. So whenever you go for learning velocity, this is what? This is the rate of change of displacement. How much something displaces in how much time you'll encounter with differentiation. or if you were to learn acceleration, again you'll have to go through differentiation, because acceleration is what? It is the change in velocity of an object. So physics is filled with calculus, and it is for the good of you. So I hope from the next time, whenever you see these expressions, you won't be afraid. This is nothing but it's just a rate of change. And yeah, that's it. In the next module, we'll learn about integration. All right. Okay. Then stay home, stay safe. Bye bye.